In this, the third episode on test doubles in Java, we're going to look at mocks. If you haven't watched the previous videos, the first on dummies and stubs and the second on spies, I will add links to those here. Today we're going to look at the next type of test double, a mock. A mock allows us to pragmatically change the responses a class or some functions will return during the code under test execution. Hi, I'm Mark Bradley and welcome to Testing All the Things, a screencast in which we use live coding to demonstrate different types of testing tools and techniques. In this video, we're going to look at mocks. We're going to carry on implementing our driving license number generator. Let's look at the code and we'll go through what we're going to do today. In the previous two videos, we had concentrated on the error cases for our driving license number generator. When an underage applicant or a duplicate applicant attempted to generate a driving license, we returned exceptions and logged that case. If we look at our tests, we can see that we used a spy test double in the previous video to ensure that logging was occurring. We looked after the code under the test had run, we interrogated our spy to ensure that it had only been called once, and that for that call it contained the words too young for our underage applicant. And we used a spy in our second test to ensure again the logger was called once for a duplicate applicant and that the log string contained the word duplicate. In both of these tests, we've also used a stub. This is a hard-coded implementation of the interface that we can use during testing. It doesn't have any functionality to it, it just returns the hard-coded values you need code under test to be in the right state when you call it. And we've also used a dummy. A dummy does as little as possible to implement the interface. So usually it just returns null if it needs to return something and ignores anything given to it. Today we're going to look at mocks and we're going to start implementing some of the happy path of our driving license number generator. And what we're going to do for this is we're going to create a mock of our applicant and we're going to create a mock of our random numbers generator. So let's have a go at that today. So as I said, we're going to test the happy path. So we're going to need a new test. So let's do new test. And we can say test valid applicant gets a license number. Let's start with some of our simple setup. For the happy path case, we don't want any specific logging to occur. We're not interested in the logging, so we can go back. Instead of using our spy logger, we can use our dummy logger. So we can go logger equals dummy logger. We're not interested in what happens during the logging at this point. Oh, sorry, new dummy logger. Here we are. So if we copy this line, okay. And we also need to pass in a generator. Now at this point, we need our implementation of the random numbers generator to be a real or have some functionality to it. We can't just rely on our dummy anymore returning null. We need to return specific values so that we know our test, so that our code under test can use that implementation when it's passed in. So we now need to create something. We now need to create a new type of test double. So we're going to create a mock. Where are we? In here. So we do new Java class. We'll create a mock driving. Random numbers generator. We'll add this. So this needs to implement a random numbers generator. Implement the method. It's a single method. So the interface requires a single function called generate random numbers or number. It takes an int, which is count, and it returns a string. In the real world, our actual implementation of this would return a string of numbers that says the length of the count. So if you passed in 2, it would return 2 random digits. If you passed in 10, it would return a string of 10 random digits. Obviously, if we're testing, then randomness is something we need to avoid because our tests should be absolute. They should we should assert on equals, not some kind of rough thing. So we want to check. We want to be able to, during our test runs, the code under test should rely on this returning something that meets the interface and meets the requirements of the interface, but we have control over, so that if we're using the digits returned, the string returned, we can then use it to assert exactly what we expect. So we're going to create a mock. What we can do here, we'll need to add some extra functionality. So we're going to do something like private expected numbers equals, and we'll give it a string, empty for starting. This needs to be typed. Yeah. So we can go public void, not return anything, set expected numbers, string expected, and we can say expected numbers equals expected, like so. Okay. Now when we call this, we can just return expected numbers. Okay, so this is now enabling us to configure the mock during our test setup, so we can return different things. We have a mock when generator equals new mock, like so. So now before our code under test runs, we can say generator dot set expected numbers, and we can say it's going to return 1, 2, 3, 4, like so. So we're now in a position where we have something that implements the interface and we have control over it in our test code. We also now need to be able to pass in a controllable applicant. So we now need to also create a mock applicant. So we'll create a new class, we're going to create a mock. Now, because we're only using this in the happy path, I'm going to say this is a mock valid applicant. And you'll see why in a second. Okay, add that. And this needs to implement the applicant interface. Okay, now I said it needs to be valid. Okay, so we're now testing the happy path. So we're going to mix a stub in with a mock. Our Boolean functions are never going to need to change for this applicant. So we can do return true for over 17, and we can return false for holds a license. We're only interested in the changing or being able to change the responses for initials and date of birth. If we create, so private string expected date of birth, equals, duplicate that, and it's expected initials, like so. Okay, and then let's just create a setter, just to make our life a bit easier. So that's all done. And we'll create a setter. That was our initials. That was the date of birth. So we'll also just setter, like so. So we can now, in our test, pragmatically change the responses for the date of birth and the initials. So now we can set up our applicant. Mock valid applicant equals new mock valid applicant. And then we configure it. So applicant dot set expected initials and be applicant dot set expected date of birth. What we can go with 23rd of the 9th 2015. Just random numbers. Okay, so we've now configured it. So our date of birth comes in the a format we want. It's just going to be day, month, year. Okay, that's because that's how we want it. So that's how our interface is defined. It's just going to return a string rather than an actual date or timestamp. Okay, so we can now call our code under test. Let's tidy this up a bit. There we are. Okay, so we're calling the generate function. It's complaining because there we go. Okay, so we're not expecting an exception this time. This is a happy path. We're expecting the license number back. So number string number equals the response, and now we can assert our expectations. So we're going to assert equals, so the expected. So this is how we expect the driving license number to be produced inside our code. So we expect the driving license number to be the initials of the applicant, MDB, their date of birth, followed by a number of random digits produced by our random numbers generator. So 1, 2, 3, 4. 1, 2, 3, 4. And that's when we for the number, like so. So that's really nice and tidy. So let's run our tests and see what happens. Our test is failing. It's failing quite badly. It's getting an exception. Okay, so we need to start solving this problem first. So let's look at our code. Let's get rid of this. All right. So at the moment, because of the requirements of our previous tests, our default behavior is to just return, throw an underage exception. We need to improve our code at this point so that it doesn't always throw this exception. So let's do that. So we can say if applicant dot is over 17, so we need to not that, add that, and then we'll return empty string. So we've now at the top of our function generate, we've got two guard statements. One that stops the execution of our generate if the applicant holds a license, and a second guard statement if the applicant isn't over 17. And then we were just returning something to make the code compilable. So now let's look at running that and see if we get past the error we were getting. Okay, and we do. So we expected our string to be this, but we actually got an empty string, which is not surprising. It's what we've hard coded right here. So we can now start using our mocks to make our test pass. So we can return applicant dot get initials plus applicant dot get date of birth no, not applicant at this point, it's random. And we'll just casting it together. This dot random dot generate, and we need 4. So if we run this, okay, so we've mucked up potentially here because we're getting 2 nulls and the string. So it looks like we've probably missed something in our mock applicant. Yes, we're not returning things, so we need to expected initials, and this should be expected date of birth. So we've made a bit of a mistake there in our setup. Let's go back and run it. And our test is passing again. That's great. So we've now created 2 new test doubles, 2 mocks, one of the applicant and one of the random numbers generator. And we've configured them to react in a certain way. However, these getters were relatively easy to mock. Now we know because these getters were relatively easy to mock because they just are set up to return something. But we haven't really fully implemented the mock around the random numbers generator because that function takes a value and given on that specific value returns a specific response. Okay, so we've just set it up so it just returns 4, but that's not particularly how we see our random numbers generator being used. We're going to move on to another requirement now of our driving license generator. We require that the license is a specific length. If you have, so our applicant here has 3 initials, they have a middle name. So the driving license number here is 15 characters long. We need to ensure that the length of our number generated is always that length and it's not shorter. Okay, that's a requirement. The length of the driving license number has to be the same. So we'll run a new test. And we will test license number length is always 15. Or always at least, let's say that. At least 15. Okay. So we now need to check our other cases. We take this test. Okay, and what we're going to do here to show the power of mocks is we're going to test a few different cases inside one test. We've got our applicant set up, MDB, but we know we need a shorter license, like so. And then we can return 5, and then this will have 5 on it. So we can do it this way, where we change both these each time, which is okay, but what we could do is we could do it pragmatically. So we could say expected numbers, and we could say when you ask for 5, you get this, and we'll duplicate it. When you ask for 6, you get this. So now we're adding more functionality, more like a mock that we'd get from a mocking framework. So we can go back to our thing. We can say numbers, so int given, so given int, and then instead of, so we're just doing this as quickly as possible. So we're just going to use a string array. It's a bit odd. We can do new string array. We'll make it 10 in size, and then we can say the given returns the expected, like so. And then here, instead of return that, we just return the count. So that allows us to have different settings in our mock for different situations. Okay. This is not a particularly great real-world example of a mock. It's just a really good way of quickly showing the power of a mock. So that's all set up and working. Just need to go back and fix this. This should be 4, like so. So now let's tidy this up. So we've got our applicant X, we'll put it in here like that. And then we can do, we can just change our applicant. So applicant dot set expected initials, then we can rerun this. And then we should be 6 now. So and we take, oh hang on, we take the D out of that one. Okay. So now let's run our test and see what we get. So our test at this point is failing because it's getting a null on the end. Because when we give it the number of things we require, it doesn't have that. Okay, so we're saying we require 5, it doesn't have anything for 5, so it doesn't know what to return. So we need to change our implementation up here now. We want to look at changing the number of random digits we add to the end. String license equals, and we'll just take this first bit. So, okay. Now, we need to calculate the number of random digits we want to add to the end of it. So we can do that. So we can say 15, we said, we'll go int num of rands equals 16 minus license dot length. Okay, so the number of additional numbers we need to add, and then we can put to the end of it the number of rands, and we just concatenate the license. Do that, and hopefully that will solve. Oh, typo. Okay, solve that problem. Back to the run. Okay. Where are we? Did I miscalculate? I think, oh, I said, no, that's why. Typo. There we go. I said 15. Let's try that again. And there we have it. Our test is passing. So in this video, we've created some mocks. We've made them ourselves rather than using a testing framework as we have done throughout this. Let's have a look at what we've done. We've got our mock applicant that allows us to pragmatically change the parts of the applicant that would change for a valid applicant. That'd be their date of birth and their initials. We can change that, we can program that however we want during our tests. And we've also made a mock of our random numbers generator. So this allows us to get and set up and receive different values for depending on what is given to that function. So depending on what the variable count is, we can configure different things. Okay, so this is kind of where we've kind of been slowly building up over the last few videos the complexity of our test doubles. We started with dummies that do nothing other than implement the interface, and then we've moved on to stubs. They do enough to implement the interface and they return hard-coded specific values that we can use in our test or in our code under test. Then last time we looked at spies. They allowed us to interrogate what happened to them after the code under test had executed. And today we've looked at mocks. They allow us to configure what should happen within that object we're test doubling during the run of the code under test. It allows us to configure stuff so that they respond and act in an exact way during our code under test. I hope you found this video on mocks useful. I'll see you again soon. Thank you for watching this episode of Testing All the Things. I hope you enjoyed it. If you did, please rate and review the video and subscribe to the channel. If you did not and you have any feedback, please leave a comment in the comment section of the video or contact me on Twitter @Bradle.